Hi, everybody. Welcome to this week. We are going to finally start learning about how to calculate dosages. Today, we're going to be covering calculating oral dosages, and it's really important to be careful when you're preparing these types of dosages. So the first thing we have to learn about is how to interpret the labels on those medications. When you take a look at a label on a medication, you're going to see a lot of different things. First, you're going to obviously see the drug name. We're going to see the dosage or the strength with some unit of measurement. We've talked about some of those things already, milligrams, things like that. We're going to see the manufacturer name. Who actually created that medication? Is it Sandoz? Is it Eli Lilly? Those are going to be some of the manufacturer names we'll look at. How much of the medication is actually in the container? So when we've got a stock container on the shelf, that may hold 1,000 tablets or 1,000 capsules or whatever, but we are going to be taking some out of that to actually fill the prescription. Also, there's going to be special instructions for care for some of these medications. Maybe they cannot be subjected to light, things like that. That determines where we store it in our pharmacy. And then, of course, there's something called a National Drug Code, or an NDC, which is a unique product identifier for drugs. And we will talk a little bit more about that as well today. So again, we have to be really, really careful when we are looking at these medications. So knowing what the drug is, what the dosage is per unit, and any special precautions are going to be very, very important. Now, when we talk about oral dosaging, what we mean is any medication that is taken by mouth. It's the most common route for most medications. So that's going to be things like tablets and capsules, as I already mentioned, but also powders or lozenges or even liquid things like solutions or elixirs or suspensions. So we're going to talk about a couple different ways to do calculations. There's the proportional method, which is what we're going to talk about first. So when we use the proportional method, all the units of measurement must be the same. So when the units of measurement are the same, then we are able to create a proportion. So we've got the known dosage over the known form, and then the dosage ordered over the amount to be given. So that's the first type, and we'll give some examples of that here in a few minutes. So that's the proportional method. So for example, 25 milligrams per one tablet. That would be dosage and form, okay? Then we have the formula method of calculating an oral dose. So in this case, all of the unit measurements also must be the same, and then you put the numbers into the formula to find the correct amount of medication. So the dose ordered over the dose available. So for example, maybe the dose that was ordered was 100 milligrams, but the dose on hand is 25 milligrams. And then we have to know the known dose form, which tells us how much to be given. So all of those things go into that calculation. So let's talk about calculating oral liquid amounts. Same procedure, but the actual unit is going to be a liquid amount, like a milliliter or a teaspoon, instead of tablet or capsule. So let's look at an example of one. So this is going to be an example where a doctor orders 300 milligrams of terramycin suspension. It's an antibiotic. The dosage that's available has 0.1 grams per 5 milliliters. So what do we know? We know that 1 gram is 1,000 milligrams. Okay, remember that from a few weeks ago. So if 1 gram is 1,000 milligrams, that means that 0.1 gram is 100 milligrams. Then we can use the formula. Ready? Known dosage available over known dosage form, dosage ordered over amount to be given. So let's set up that proportion. What do we know? 100 milligrams per 5 mils. Because remember, it was, I'll go back one slide, it was 0.1 grams per 5 mils. And we said that 0.1 grams is 100 milligrams. So 100 milligrams per 5 milliliters. That's what goes on the one side of your proportion. We need to give 300 milligrams. So that goes on the other side of the proportion. Now we're ready to do some cross multiplication. 100 milligrams times X number of mils is going to be equal to 5 milliliters times 300 milligrams. So that's 100X is going to equal 1500. We divide both sides by 100, so therefore X is going to be 15. So that means our dosage is going to be 15 milliliters. So that's great if we're given all of that information and we just have it written out for us somewhere, right? But what about if I have to actually look at a label? So here's an example. We've got a physician who's ordering Klonopin, 1 milligram for a patient with hypertension. That's high blood pressure. You can see the label here. We're trying to figure out how many tablets do we need to give? Well, first we have to look at the label. You will notice when we look at this particular label, right here, it says it's 0.5 milligrams. Each tablet contains 0.5 milligrams. So 0.5 over 1 is going to equal 1 over X. So 0.5 over 1 is going to equal 1 milligram over X. 0.5 times X is going to equal 1 times 1, which is just 1. We divide both sides by 0.5, so X is going to be 2. So the patient's going to need to be given 2 tablets of the Klonopin. Now, I know most of you probably looked at that and went, well, I already knew that. I could just look at the label and say, well, they're getting a 0.5 milligram in the tablet, and I need 1 milligram, so I'm just going to give them 2. But keep in mind, it's really important to understand how these proportions work so that when you get more difficult or more complicated problems, you can be able to calculate from there.